What we are going to do is we are going to figure out the level order traversal for a binary tree. We'll also use almost the same code for a depth first search also, and both of them we are actually doing in an iterative way. This is not recursive, it's an iterative way. So the algorithm for that is basically what you do is, and I want to print them in different levels. So I want to print 1 on the first level, 2 and 3 on the next line, 4, 5, 6, 7 on the next line, 8, 9, 10, 11 on the next line. So basically what we have to do is we actually have to find out a separator for each particular level. So what we'll do is we'll take a separator which is null. So null will be basically a separator. So first what we'll do is we'll take a queue and we'll add 1 and we'll add a null inside this queue. And then we'll actually go in a while loop. It can be while true, but I don't like while true. I'll say while the queue is not empty, I'll pop out this element. So I'll pop out the element and I'll say, what is the element? Element is not null. So if it is not null, I'll just print it out. So 1 comes and I print it out. Does 1 have children? Yes, it does. It has 2 and 3. So I'll put 2 and 3 inside this queue. So 1 is gone. 2 and 3 is there. So then a null comes. When a null comes, then that means that there is a new level. So null represents a new level. So as soon as we see a new level and the queue is not empty, we basically add a new null in the end. So this one will signify that all these elements, so if you can see over here, 2 and 3 are at level 2. So this is level 1, this is level 2. So 2 and 3 are at level 2, so we come over here. So then what we do is we pop out another element or we dequeue another element. So 2 is there, so we print 2. 2's children is 4 and 5, so we'll actually add 4 and 5 over here. And then we pop out 3 and we print out 3, so 3 is gone. 3's children is 6 and 7, so we'll actually add 6 and 7. Then comes another null. So when another null comes, we actually add another null in the end. So this null goes away, which means that it is actually a new line, new level. So then 4 and 5 comes. 4 has a child 8, 5 has a child, so we'll print 4, we'll print 5, 5 has a child 9, we add that. Then 6 comes, so 6 has a child which is 10, 7 has a child which is 11, so 7 comes, a new null comes, we add another null over here. So that goes away. 8 does not have any child, we print 8, so that was the third level. Then 8 and 9, 8 gets printed, 9 gets printed, 10 gets printed, 11 gets printed. We remove a null. When we remove a null, the queue is actually empty. Then that means that there is we are done with it. So we'll just quit out of it, right? So that's the iterative way of doing things. Let's actually write it's pretty simple algorithm. We'll just write that over here. And we'll come over here and we'll say public void, this is level order. So this is level order. So we'll come over here. First what we'll do is we'll check if root is equal to null, we just return. Otherwise, what we do is we need to take a queue. So we'll take a queue of t, queue of node of t. We'll actually add nodes. Queue of node of t, queue of node of t, and we'll say queue is equal to new queue, new linked list, sure. Linked list is fine. Then what we'll do is we'll add the root as well as a null. We'll say queue dot add, and we'll add the root, and we'll add a null. Because at the root level there's only one element, so that is basically null. Then we'll actually go in a while loop. While queue dot is empty is actually not true. So while that is not true, what we'll do is we'll dequeue the node. So we'll say node t, and we'll say node is equal to q dot remove. Remove. So we'll remove the queue. Then we'll check if node is not equal to null. If node is not equal to null, then that means what we need to do is we need to print it out. So we'll say, so print, and we'll print node.data, and we'll add a comma or something. Okay, we do that, and we'll check if node.left exist is not equal to null, which means that node.null exist. We will say q.add node.left, and we'll do the same for the we'll do the same for the right. Okay, so that was the case when the node was not equal to null. If we come over here, then that means there is a change of level. So we'll go to a new line. So we'll go to a new line. And then what we'll do is we'll check if q dot is empty. If q is empty, then we need to break out of this loop. Why? Because like if we don't do that, it'll go in an infinite loop. If the queue is empty, we'll break out of this loop. If not, we'll actually just enqueue a new null. Dot add null. This null signifies another level. So we do that, and I think that should basically do it. What we'll do is we'll actually go to we'll go over here, and we'll actually take a create tree, this one. So we go to main, and we'll have a function called create tree. What this will do is it basically creates this entire tree for us. It's a static way of doing things right now. So what we'll do is we'll come over here, we'll say binary tree of an integer, and we'll say tree is equal to new binary tree, and we'll say tree dot root is equal to create tree. Okay, so we get both of them, and then we'll say tree dot level order. So let's run this and see if that works. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11. So that is the case when you actually want to go level order. But let's say I want to go from 1, I want to go to 2, then I want to go to 4, then I want to go to 8, then I want to go back, and then I want to explore 5 and 9, and then 3, 6, 10, and stuff like that. So if you want to do that, the only thing that will change over here in the binary tree is instead of queue, we'll actually use a stack. And since there's no levels and stuff, we'll actually not have a level. So we'll just copy this, and this is iterative way of doing things. So it's like Control C, and this is end of level order. Okay, so we'll just paste it, and we'll say this is depth first iterative. This is an iterative way of doing things. So instead of queue, what we'll do is we'll take a stack, and this will be a stack, and we actually won't get this. We will probably rename this, and we'll call this stack, and we'll say stack.pop, and we actually don't need any of this. Okay, so we come over here, root is null, we return, otherwise we take a stack, and then we actually add the root to it. While the stack is actually not empty, we'll pop out the root, and we'll print the data, and then if the left is not null, we'll actually add the stack.pop push. I think push works, and this should be push also. So we push the left, we push the right, and then we come back and we continue doing that. I think that should actually print all our values. And then Command J SOUT, we just print the line. Let's actually try to do node. Oh no, main. And we'll come over here and we'll say tree dot depth first search iterative, and we'll say run. So we get 1, 3, 7, and 11. 1, 3, 7, and 11. Okay. It actually goes on the right side first, because first we are putting the left and then we are putting the right. So we are putting the left first and then we are putting the right. So it'll basically go to the right side. So it'll go to 1, 3, 7, and 11. And then after that, it'll go to 6 and 10. So 6 and 10. Then it should go to 2, 5, and 9. 6, 10, 2, 5, and 9. And then after that, it should print 4 and 8, which is doing that. Okay. This is the basically the depth first search. This is iterative. We have taken a stack over here. But if we do the recursive one, we just keep doing the recursive calls. So recursive calls are basically just a stack. So it's basically the same thing. We'll be doing the recursive one too in a later video. Okay, so that's it. Let's move on to the next video.